Hi, and welcome back to Dr. S's Random Math Layer. Today's video is about the slope-intercept form of a line, which is one of the most basic ways to express the equation of a line, in the xy plane. It is given in the form of problem 4. This topic is usually covered in a typical freshman high school algebra, or geometry course. Here's the statement of problem 4. Solve the system of equations star, given by x minus 2y equal to 2, and x plus 3y equal to 7. Then, using the slope-intercept form of a straight line in the xy plane, graph the solution. Before we solve problem 4, here are some quick facts and review we will need. The slope-intercept form of a line in the xy plane is given by the equation y equal to mx plus b, which we label as 1. Here, m is the slope of the line, and b is its y-intercept. These terms will be defined subsequently. Let x1 y1 and x2 y2 be any 2 points on the line. Then the slope m of the line is given by the ratio delta y over delta x, where delta y is the difference in the y values y1 and y2 and delta x is the difference in the x values x1 and x2. We have the following properties of the slope m. M equals 0 for horizontal lines. M is undefined for vertical lines. M is strictly positive for lines slanting upward from left to right. And M is strictly negative for lines slanting downward from left to right. Finally, the y-intercept b is where the line crosses the y-axis, and it is determined by setting x equal to 0 in 1. Note that the x-intercept, where the line crosses the x-axis, is determined similarly by setting y equal to 0 in 1, and solving for x. It turns out that the x-intercept equals negative b over m, for which m must be non-zero. Now let's solve problem 4. We begin by solving the system star. Multiplying both sides of the first equation in star by 3, multiplying both sides of the second equation in star by 2, and adding, we obtain 5x equal to 20. This implies that x equals 4. Substituting x equals 4 into the first equation in star, after rearrangement of terms, we have negative 2y equal to negative 2, implying that y equals 1. Therefore, the solution to star is x equals 4, and y equals 1. Now we would like to graph the solution using the slope-intercept form of a line in the xy plane. So we can write the first equation in star as negative 2y equal to negative x plus 2, which we label as 4.1. Dividing both sides of 4.1 by negative 2, we obtain the equation of the line y equal to 1/2 x minus 1, which we label as 4.2. Line 4.2 is in slope-intercept form, with slope 1/2, y-intercept negative 1, and x-intercept 2. We still have more to do, so we shall continue solving this problem next. Let's continue solving problem 4 from where we left off. We write the second equation in star as the equation of the line y equal to negative 1/3 x plus 7/3, and label it as 4.3. Line 4.3 is in slope-intercept form with slope negative 1/3, y-intercept 7/3, and x-intercept 7. Using this information, we can plot the graphs of lines 4.2 and 4.3 as in figure 1. The point of intersection of the two lines 4.2 and 4.3 is the point 4,1, and in fact, this is precisely the solution x equals 4, and y equals 1 for the system star. In figure 1, observe for instance how the line 4.2 is constructed. Clearly, the y-intercept at the point 0, negative 1 is on this line. Since this line's slope is 1/2, using the y-intercept as the starting point, we can plot all points to its right by vertically moving up 1 unit and horizontally right 2 units successively, between each point. Likewise, we can plot all points to the left of the y-intercept by vertically moving down 1 unit and horizontally left 2 units successively, between each point. Similar observations can be made in the construction of line 4.3. Please let Dr. S know if this may not be clear to you by leaving a comment or sending him an email.